Okay, before I actually do any of the questions from this section, I want to kind of talk about what's happening with the questions that they're asking you. Because if you understand what they're asking, you're going to be able to answer these questions a little better. It's going to make a lot more sense. Right now, you might look at these questions and you see relative max, relative min, increasing, decreasing. You're getting positives and negatives and solving for zero. And what does it all mean? Well, let's figure out what it all means before you do the work, okay? So I've got a picture right here of a function. Doesn't matter what the function is, it just happens to be a function, and it's a function that I've drawn. And so I want to talk about what the questions are that they're asking first. One question that they might ask is, where is f of x increasing? Okay, so we've got this function, we'll call it f of x. You probably can't see that because it's really light. Let's try something else. We've got a function here, f of x. And we want to know where it's increasing. Okay, well, you've got eyeballs. You can see this. It's increasing here. It's going up, right? That's what increasing means. The function is going up. It's increasing here because the function is going up here. So I'll kind of make some little up arrows. It's increasing. It's increasing. We can see that, okay? Doesn't matter how we figure that out from a function yet, just so that you know that when I'm asking, is the function increasing, what I'm asking is the function going up in value? As we go over on the x's, the y's are getting bigger, but that's not what's important. What's important right now is that the function is getting bigger. If you want to know where the function is decreasing, look at the picture. It's decreasing because the values are going down here. So you can see how the function's decreasing at that point. So if I showed you this picture and said, where's the function increasing? You're going to say, Michaela, it's going up here and it's going up here. And I'm going to say, absolutely right. Not that tricky. If I ask you where it's decreasing, you're going to say, it's decreasing right here. It's going down here. And I'm going to say, congratulations, you got it. It's absolutely decreasing there, okay? So when they're asking for increases and decreases in the function, this original function, f of x, that's all they're asking. Where is it going up? Where is it going down? The other question that they might ask for you is, where are the relative minimums and maximums on the function? That's not any harder if you understand what the words are meaning. So a relative maximum means that there's a spot on the graph that's higher than all of the other spots around it. Maximum, bigger. So we find any places where there's kind of a peak. A relative maximum is just going to be a peak. This spot is taller than anything else around it. The numbers are getting smaller on that side. They're getting smaller on that side. So this here is a relative max. Okay? And the same thing for the relative minimum. You find like the valley, the lowest point, where nothing around it is any lower, and that is the relative min. So if you're looking for maxima and minima, you're looking for places that are bigger than everything else that's around it or smaller than everything else that's around it. Okay, so once again, not rocket science. When you're looking at the graph, you can see where the peaks are and you can see where the valleys are. Peaks are relative maxes, valleys are relative minimums, okay? So that's the picture of what they're asking you. The question is, if they give you a function, how are you going to figure this out for yourself? And what you need to remember, the thing that you need to remember when figuring these out is what we said when we started looking at derivatives. If I give you a function f of x, make sure you can see what I'm writing there, okay? If I give you a function f of x and I ask you to find the derivative of it, f prime of x, one of the things that we said the derivative was, because there were a lot of things that it was equal to. We talked about it being equal to, let's see, if I say derivative, it means f prime. If I say derivative, it means instantaneous rate of change. If I say derivative, it means the slope of the tangent line. That's the one we need. You need to remember that f prime of x gives us the slope of the tangent line. That's the super important thing that you need to take away from this. So the slope of the tangent line. Okay? So we have a function. It looks like this. If we found the derivative of the function, it would tell us the slope of the tangent line at any point along this function. We would just plug in an x to our derivative, and it would tell us whether the slope is positive, whether the slope is negative, or whether the slope is 0. If the slope is not changing, that's another important thing, okay? So if I give you an f of x and I'm asking you questions about that function, in order to figure out where it's increasing, where it's decreasing, and where the relative maximums and minimums are, you're going to have to take the derivative first. And that's because the derivative is going to tell you slopes. Okay? So if we take the derivative of the function f of x and we plug in a value and the answer we get is positive, what that's telling us, and actually I'll go with a lighter marker this time, what that's telling us, say I found the derivative and I ask you to plug in this point here. It's got an x value, we'll call it, we don't have to call it anything. I ask you to find the derivative at this point. You plug in an x value to your derivative function and you're going to get the slope of a tangent line. The number it's going to give you is going to be the slope of this line here. If that number is positive, if the slope is positive, that means that the function is increasing. And of course, since our function's increasing here, if I drew a tangent line, the tangent line is going to have a positive slope. So I don't have to see the picture. I just have to calculate a derivative at a specific point, and it's going to tell me, if it's a positive number, that my slope is positive there. So the function is increasing. So we'll actually write that down. So we'll write it down here. If f prime of x is positive, at some x value, the function f of x, that original function, is increasing at that point, okay? I'll write the point here. All right, so make sure we can see it. If f prime of x is positive at some x value, you plug in whatever that x value was to your function and you get a positive number out of it, that means that at that point the function is increasing, okay? If you were to plug in, if I asked you to plug it in at x equals 0 here, your tangent line is going to be negative, right? That f prime of x, when you plug in that 0, it tells you the slope of the tangent line. That slope is definitely going to be negative there because that's what the function looks like at that point. So if you plug in x for some x value into your derivative, so here we go. If f prime of x is negative, and kind of fill in the blank at some x value, then f of x is increasing at that point, okay? All right, so, decreasing. All right, so if the slope is negative, then the function is decreasing. All right, so what's the only other thing that can happen? Because we can have a positive slope and we can have a negative slope. The other thing that could happen is we could have a slope that's equal to 0, right? At these points right here, at these peaks and valleys, our tangent line, the slope is going to be equal to 0, okay? So if I ask you to find relative minimums and maximums, you're going to need to go and find the places where f prime of x equals 0, all right? So if you plug in, if you set f prime of x equal to 0, whatever comes out is going to tell you the minimums and maximums, because we know that a 0 slope means that everything around it is, you know, it's kind of coming to a peak. In this case, the reason it's 0 is because everything is coming up to it and then going down from it. In this case, everything's going down to it and then coming up from it. You have this one magical point where the slope is equal to 0. So if you set f prime of x to 0, it's going to tell you where the maximums and minimums are. So that's what these things mean in pictures. And so if you find yourself getting stuck in the questions, try and think about what the pictures are asking you. If they're asking for increasing and decreasing, what they want to know is where f prime of x is positive and negative. If they're asking for relative minimums and relative maximums, what they're asking for is where f prime of x is 0. Okay, so now I'm going to go ahead and solve some of these questions for you. But keep this in mind. Go back and look at this picture. If you can't remember, what does a relative max mean? Well, a relative max is just the high point on a function. It's like a high point, it's a peak, and it's got a slope of 0, and everything around it is coming up to that point. Relative minimum, same idea, except this is at the bottom. So it's got a slope of 0. It's a little valley in our function, and everything, there's nothing lower than it. Everything on this side is higher, everything on that side is higher, so that's why it's relatively minimum to everything around it. Okay? So on to solving some of the questions.